Overhand Throwing versus Underhand Throwing by Kylie, Lexi, and Michael. Today in this video, we are going to be showing you the difference between throwing a ball overhand and throwing a ball underhand by measuring the amount of time it takes for the ball to get from point A to point B with each throw. Doing this, we'll be able to determine the velocity of the throws and figure out the strength of the forces that are acted upon the ball each time.
In order to figure out the difference between over and underhand throwing in terms of speed and force, we needed to figure out a few things first. We threw a ball back and forth both ways and collected the data we needed. We discovered that the ball weighed 0.1 kilograms and it traveled 4.7 meters.
What we're trying to find is the difference in force of an overhand throw compared to an underhand throw. We already found the total distance, the total time the ball took to travel the distance, and the end velocity when the ball stopped. But I'll show you how to find the acceleration using one of the big five equations, since it was a little harder. We assume that the distance traveled is the same for both balls and that the height of the ball did not change. I'll plug all of the numbers into the equation and it should get the acceleration. So the acceleration of the ball in the overhand throw is 6.527 meters per second squared. Meanwhile, the acceleration of the underhand throw was 11.595 meters per second squared. Using the second Newton law, plug the acceleration and the mass of the ball into the equation. Net force equals mass times acceleration. The applied force on the overhand throw is 0.6527 newtons and the applied force on the underhand throw is 1.16 newtons. Therefore, the applied force on the underhand throw is greater than the applied force on the overhand throw.
Thank you for watching our video. It was edited by Lexi. The math was done by Michael. And the illustrations were done by Kylie.